Okay. Oh. Ah. Right. Ooh. Ooh. Ah. Okay. Welcome back to this Learn Programming with Rust. So we'll continue with tutorial where we left. Right, just a quick recap. Okay, we learned about if and assignment. So general, the reason we write program is to do calculations. So besides calculating numbers like this, times 5. We also learn about finding the remainder of a division. Then we also learn about assignment, where we store a value number, text, boolean, true value, etc. into a name. So for example, we have this random name equal to 10. The reason we store the value into a name is because we want to somehow use it later. So for instance, you can do this. So then you get 100, because some random name will be replaced by 10, as in line 7. 10 times 10 becomes 100. Also, you can store a result of the calculation to a name. Some times. Then some computed value will contain the value of 150. Then you can use it calculation, or can create a new name, to store the value, and times 30 points. This is also possible. So after we learn about assignment, we moved on to learn about true value manipulation, because previously all we learned numbers. We manipulate numbers, we do something with it, we assign it to a name. Then we moved on to do true false evaluation. So when you see, as you see here, this line 6, we have 3 modulus 2. Assume we want to know whether 3 is a even number. So according to number theory, if a number is divisible by 2, the remainder, that means the remainder is 0. So if there's a comparison operator here, this will yield a value of true or false because of this operator here. So in this case, 3 modulus 2 is 1 because the remainder is 1, which is not 0. Therefore, this gives you a false. Also, we learn about other things that gives you true or false values. For instance, you have comparison operator like 3 smaller than 2. This should give you false. 3 greater than 2. This should give you a true. Or that's also greater or equal 3. Greater or equal to 3. This is true. 3 greater or equal to 2. This gives you a false. Also, there's a less than or equal to 2. Less than equal to 2. False. All this kind of calculation gives you a true and false. Then it will be useful when you construct a if statement, which is the branching part of the tutorial last week, where the general form looks like this: if some condition and do something. The condition part here can be replaced by any kind of expression that yields a true or false value. For instance, we want to know whether a new name is an even number. If it's an even number, the remainder is 0. Then we will do something about it. Maybe print something the result of and every sentence with a semicolon. There are exceptions to this, but we'll talk about exceptions later. Okay, so this is more or less about it. And also you can do else statement, else clause, where a new name, when it divided by 2, returns a remainder. So we can also do something that handles that kind of situation. You will do whatever you want according to what you want to achieve. Also, if let's say you want to test more than one things, instead of writing just else, you can also expand this in else if new been fine and do something like that. Or for instance, then it will be up to you whether to, yeah, again, else is always an option. You can do whatever you want. Please skip this part. When I say skip this part, that means this whole thing is not needed. Right? So this is it. Practically, this is what I covered last week. With that being said, let's move on to what we are about to cover this week. The first thing is repetition. Often when you write program, you would want to repeat certain things, like printing a number or even a series of numbers, one line after another. On two, so you can see 5 lines of command, 5 lines of code, 5 lines of output. Oftentimes, this is the best solution. However, this might not always be the case. For instance, you are asked to maybe write 100 of them. Then you will have to repeat this same thing 100 times, which is not something I would say ideal. Doable, but not ideal. And you will hate yourself after doing that because it's just endless copy and pasting, which is very counterproductive. So, in order to do it in a smarter way, before we start everything, I would like to introduce a concept of counter. A counter in this case is a number which tells you how many times you have been doing the same thing. So for instance, maybe back to the case now, I may want to introduce a counter between to indicate the same kind of code is being ran how many times. So for instance, this has to be mutable because yeah, if you don't put a mute there, even though a counter is a variable, Rust will complain that the variable is not mutable. So we'll be having this counter has been run once. I mean the code has been run, similar code has been run once, twice, 3 times, 4 times, 5 times. Okay, I hate myself already. 6. 7. 9. 10. Right. So we have 10 things here. The reason for the counter will be explained soon. Alright, Wait. Okay. Back. Right. Now we have 10 things. The code still runs, but it's not used. Rust will complain that I've declared this, but it's not used. However, this is a warning, so generally it's safe to ignore. But however, the best practice is to not. But for now, we shall ignore this for now because there's a reason I introduced a counter in here, right? The result is still the same. I get 10 lines of output from 1 to 10. Alright. Now, this sounds very silly, isn't it? So, if you read through the program, this is a program, you'll find out that if I reverse the order of counter and the print command, the print statement, I can do this instead. Instead of printing one print counter, or maybe some sort of manipulation that involves a counter, but in this case I'm just printing counter. So instead of printing this manually, I can just print count the value of counter after every change of value there. Oops, made mistake somewhere. Yeah, this is why we have a special way of dealing this instead of copying and pasting, because it's very annoying to do this. Yep. Okay, we ignore the warnings for now. So this is the execution, and it is still what we wanted. Okay, now let's try to introduce. Let me introduce a new thing, which looks very unrelated for now. Let's make a series of numbers. Right. Series of number is defined by the start value, in this case 1, and then equal sign if you want an inclusive series. In this case we want inclusive series that ends at 10. So the series ends at 10. So let's see what is stored inside. Series. So we should see something that happens before that. Yep, exactly what we find here. Alright, now let's move on to writing a loop. In this case, we shall start with a for keyword. keyword is something that has to be in this way, and they usually come with a set of pattern that you need to satisfy. So in this case, for name in series. It's actually an iterator, but for now we call it series, and we do something about it. So a name, in this case, let's fill in the blanks with what we know so far. So a series is this. You can either put series, as we define here, or in this case we put one, so we do not have to write this. Then we replace the name to the counter. Right? So what this does is, you'll see later. So what this does is, a value is being assigned to counter whenever things happen. Oh, I also need the lab. Oh yeah, forget the syntax for finding. Yeah. Oh yeah, so forgetful. So this is when the documentation is useful. So in this case, I need I64. We'll talk about this later. So what this does is, this is actually a series of number, as I told you just now. Like, so you get 1 to 10. So what this does is, for all the numbers 1 to 10, it will be assigned to this counter of one after another. So this statement, whatever that's defined inside these two braces, will be done 10 times from 1 to 10. So when each time it happens, the value of counter is changed. So instead of writing 10 lines in the beginning, we only need at most like 1, 2, 3, 4 if you count this as a line, like 4 lines instead of writing 10 lines. Please work, please work, please work. See. Yep, we still achieve the same result where 10 lines of things is being returned. Oh, we don't even need this line. Yep, we don't even need that line. So in the end, we only need 3 lines if you count this as a line. So 3 lines instead of writing 10 lines, and you get the same result. You can 10 numbers being printed to the screen, one in a line, each in a line, right? So this helps when your boss asks you to maybe write 100 lines of numbers. So instead of copy and pasting 100 times, just change the series here, and then you get whatever you want being done repetitively. like so. Of course, you do not really have to do things rely on the counter. If you know you want to do the same exact things 100 times, for instance, you can just disregard the value of counter and then put maybe a print 10, for instance, in 10 100 times. It will still work, and you will still not having to copy and pasting the same line over and over again for 100 times. You only need the same 3 lines. The reason I put some underscore here is to avoid having it's actually not a big deal, but as I say, you want to avoid hitting warning as much as possible. So it's also a good practice to assign name a variable starting with an underscore where you only need it once. Yeah, the point is still you don't have to write same thing over and over again for 100 times, 200 times, 300 times. All you need to do is just changing the value of the end value. Then you get your result. So okay, now you may wonder, what if you really want to put text onto the screen instead of just numbers? It's not that difficult, but text manipulation is not something that I want to touch on this tutorial a lot because there are some exceptions here and there on how Rust handle string text data. But I will just talk about it briefly. What this print line thing does. So print line takes mainly, it requires at least one thing to be passed in. So all this while we've been doing this and put a value after the comma. However, you can actually print text directly. So in this case, we have 100 hello world here. As long as it's enclosed by this double quotation mark. Yeah, we have 100 hello world. Then the reason I want to introduce this because I want to write a real program using what we know so far, iteration and repetition. So the requirement of the program is like this. It's a very popular programming quiz when you apply for a job. It's called a FizzBuzz test. So given and numbers be so and if n is divisible by 3, we print this. If n is divisible by 5, print a buzz, hence the name FizzBuzz. Otherwise, we print the number, right? So now the way to start this is assume we already have n. So we have a let n equals to something somewhere, right? Assume this is already written. Assume this is written somewhere. Let's start by writing computer code that satisfies the second requirement first, which is check whether a number is divisible by 3 or divisible by 5. Okay, the way to do this is obvious. We go back to the branching where we have if statement condition and do something. In this case, we need to do two tests. The first is whether n is divisible by 3. The second is else another condition do something. Then if these two conditions does not match, then else do something. This is the general form. Let's assume we have n set somewhere, n being assigned somewhere. And let's start writing code that fulfills these 3 lines. N is divisible by 3. N divisible by 3 equals to 0. We print a fizz. Easy. Just told you how. Is get exclamation mark after print. The second one, if n is divisible by 5, almost same thing. Int 9 plus otherwise print number. And n. Right, this looks fine. Let's run. Now n is 100. Okay, plus because n is divisible by 100 is divisible by 5, 0. Right, the compiler doesn't like variable that starts with capital letter. Change it. Small case. Things should still run. Alright, let's put in a number that's divisible by 3. Let's say 99. It should print out this. Yes, it does. About a number that doesn't satisfy both conditions. Will it print the number? Please work. Oh, this is slow. Please don't die. No, I'm doing a live. Don't die. Okay, it works. This part is executed. Alright. What if we put a number which has a factor of 3 and 5? Say 15. Prints a fizz. For purpose, we did not say that it has to be either one. We assume when n is divisible by both 3 and 5, we want both. Because there's no, the requirement doesn't say that or you only need to print one. So in order to do that, this is an edge case where things break on these special occasions. Okay. let's extend the if statement a little bit. Alright, last week there's one thing that we covered but I forgot to do a recap, is some Boolean type operators, which is and or not operators. So in this case, clearly we need something that says if n go by 3 and n is divisible by 5. So in this case, we want both fizz and buzz. Fizz, buzz. Let's see if this works. Now that we've changed it, yeah, it works. Means fizz buzz instead of just fizz or buzz. Right. Now this is done. But we still have not satisfied the first one. Given n numbers. When we see given n numbers, that means a series has to be involved somewhere. So go back to the form of for. For takes a pattern of this name in series, then we do something about it inside the for part is a for loop. Alright, so the name is obviously n, because all this while we are dealing with n. A series, what's the size of the series? N numbers. In this case, we assume n is 100. So let's do a series that starts from 1 and ends 100. Actually, instead of writing this, we can also do this. We will end at 100. But recently, Russ added this so that it can be clearer when to see if n value is involved. So we just keep it this way. Okay, the do something thing, we can actually copy and paste, or rather cut and paste this part, put it in. Because this part of block, it only cares about the value of n. It doesn't care about this. All it cares is the value of n. So instead of writing this 100 times, this if statement 100 times, you can put it inside a for loop and paste this entire if block into this for loop so that it runs the number of times that you define here, which is 100 times. Alright, it doesn't like the parentheses here. But again, yep, this works as expected. 1 is not divisible by 3, not divisible by 5, so it prints number. 3 is fierce because it doesn't satisfy this, but it satisfies this, so of this. 4, 5, 6. 6 is a multiplier of 3. 7, 8, 9. Again, multiplier of 3. 10, multiple of 5. Right? 11, 12, 13, 14. Oh. Alright. This is a simple introduction to a loop, or we call that it's the third important thing I think of. Okay, now we learn about loop. Next we learn about reuse. Now back to the very backbone of program. The minimal amount of things that you need to type on the screen in order to run is just this. Nothing is happening because nothing is defined inside. So this is a function. We usually call this a function. So a function is written this form. So we start with keyword fn, stands for function. Then we require a name, just like we require a name for variables. Brackets, braces, and inside braces is always the do something. Okay. What is the reason of writing a function? So a function is written because sometimes there are things that we need to do repetitively, a lot similar like what we require from loop. However, there are some small differences between a loop and function. For instance, you may have a program that does this. At m equals to 0, in the value of m 7 m suitable, then you want to print value. Okay. So then you will notice somewhere in your program you also have this. Instead of 7 times 8, maybe you want 7 times 9 this time. Then somewhere further in the program you might have something like this, maybe 7 times, and etc. etc. This is a perfectly fine program. Not perfect. Stop. Yeah. You see different results despite having the same pattern, right? They look similar. The only difference is, oh, okay, this is different. The multiplication part is different. Something is different. That's all that is different. So we can do this with a loop, no doubt about it. However, there's also another way of doing this, especially when you have very complex algorithm being written, but each time you run it with different value. For instance, assume this is a very complicated algorithm, mathematical algorithm. And this is what makes every run different. The argument is different. So in this case, we can write a function that receives or does not receive an argument. A function that does not receive an argument, they runs the same every time you call it. So the way you call a function is, okay, you can copy and paste however many times. This sum function will always give you the same result. It prints the same thing over and over again. Every time you call it, prints the same thing. Hello world, hello world, hello world, hello world. However, if you make it receive a value, it can slightly change the behavior of the function. Let's say we are writing something very complex. It's a very advanced, exotic, powerful, mysterious mathematical algorithm that takes a number. Let's call it n. And then this n is a number which we really need to define, I64. If this looks familiar to you, it's because I just now wrote something like this, and and right, if this looks familiar to you, this is what I wrote just now. However, when you write a function that receives an argument, you need a name followed by a colon, then a data type. In this case, we only talk about numbers. So according to the documentation, these are what you can write inside there. So in this case, we want a number. So usually I64 is fine, I32 or I64 is fine. Or we will just go with I64 for now. You can read about a chapter or data type in your documentation if you have time. But for now, let's settle with just I64, which is a number that we require for our very complex, advanced, magical algorithm. Then we copy and paste this in. Assume this is our super powerful complex algorithm. And then we replace n by m, the number by n. Let's see if they gives us the same. Let's print something that differentiates different function. One. Okay. The way we call a function is we start by the function name, complex, followed by a pair of brackets, parentheses, and then we end the line always with a semicolon. So in this case, we require a number as a parameter, as an argument, because we need number that we can multiply inside our function. So in this case, the number is 8. We put them in like so. Let's compare. Not a function. Right. Not a function. That's 0 and 50. One argument, 0 and 56. Exactly the same output. Let's try with another case. Not a function. One argument. Bring and number here is 9. We run again. See if we get the same result. One argument, not a function. 63, 0, 63. Exactly the same again. Let's try again. And paste. This time the value is 10 instead of 9. Or 10. Works. On a function 0, 17, 70, one argument 0, 70. Okay. Let's say we need another number in our complex algorithm. All you need to do is just continue the list with after ni64 new variable I, another data type, which is i64. So here we replace this 7 by e. Right? When you call the function, you need to make sure you always pass in the second number. If you don't, you get error like so. We take two parameters. We require two parameters, but in line 46, we only pass in one instead of two, like line 28. So what we should do is we do the same thing for line 36 and line 46. Then we run. Oh, we run. This time we have two arguments. For the function, two arguments, again the same result. 63, 70, the same result. Okay, so you can clearly see that instead of having to write the same thing over and over again, one time here, second time, third time, you can actually just simplify everything and reuse the similar code like so. Just now, part takes about 4 lines. Instead of 3 times 4, 12 lines, you only need 3 lines. Of course, you can also put this into a loop, which is perfectly fine. So you don't even have to write this statement 3 times, which is fine. Just put it into a loop for n in 8 starts from 8 to 10. Then we only need to do this once. Which also work. Don't like the parentheses. Okay. Yeah, the point is still using a function and a loop is not a mutually exclusive thing. You can use it together to achieve what you want. The point of writing a function is you can put a lot of similar things into a function so that you don't have to write it over and over again. You can say this a loop and a function is just two different ways of doing the same thing. But remember, if you write it as a function, remember that the program runs from top to bottom. So you can have situation where algorithm you can have this 4 lines of code required here, and then you will probably do some other complex stuff in between. Then you may mix a if statement thing between. Then we'll go back to complex. Nine. And they may not happen like consecutively, as there are things that has to be done in the middle. So this is when a function is useful, not just a for. Because in this case, a for is not applicable here, even though you may have a algorithm, and then in the between you might have another for loop for other purpose stuff. Then all of a sudden you need to so you may have this kind of situation where a for loop is not applicable to things that look similar. So in this case, you don't want to repeat these 4 lines here, here, and here, and here. In this case, you put the similar parts into a function, then you take the difference as a parameter to be changed whenever needed. So in this case, 7, 9, 7, 10, 7, another 10, 7. So it does not has to be in a loop, especially in the middle. There are things that you need to be done that may not be done later. So yeah, this is generally the idea of having a function. So you may be curious why there's no exclamation mark after the name of function like we do for print line. The short answer is print line is not a function. The long answer is print line is actually a macro. But Generally, they solve the same kind of problem, which is a reuse problem, where you don't want to write the same thing, similar things over and over and over again, right? So this is the point of having a function. There's also one thing a function can do. It can also return a value. For example, you have if give me value of, remember the mx plus c linear function thing. So x on the number, we want the value of y, which is at I64. These few characters after the bracket is indicating that I want a value that is computed after I call this. So we have result equals to m x c c. Then we would love to return the value. What can this do? This is done such that, remember assignment again, everything is actually tied together in of programming. So when you do assignment, y can be a number, a variable can be a number, a variable can also be a result of a calculation, and 20. It can also be a calculation that involves another number, and also in this case it can be also a value of a function, the result of a function. Give me value y, where m is 10, x is 20, c is 2. This should work. Yes, this works, but it does not print the value. Let's print out the value and see. Thanks. Alright, print it. Yep, the value is out. 10 times 20, 200, 200 plus 2, 202. Y is 202. This works like we wanted. We have value of y, which is a computation of this parameters, and we return the value, and then we assign it a variable, then we can use it later. Z equal to y plus 20. Then we print the value of z. Two. So this is what we want to achieve by introducing a return to we call this a return. Another trick that only happens in Rust. So all this while I've been telling you that you need to end everything with a semicolon, which function very much like a period sign in an English sentence. However, there are exceptions to this. So for instance, you can choose to not write a semicolon, omit the return keyword by just this. Let's see if it works. it still works. So in this case, when we expect a block which is surrounded by these two braces to return a value, so in this case we expect it to return a number, we can leave the last line in the block which is surrounded by these two braces without a semicolon. This is equivalent to having this. They are equivalent to each other. So you can either write this or write this. But in Rust, we usually would advise to keep it in this form, which is the no semicolon form. And we usually call this an expression because it returns something, returns a value. Whereas you also have the lines with a semicolon. This is what we call a statement because it doesn't return a value after completing this line. So these are the main difference between the expression and statement. So if you end function block with an expression, the type of the expression, the return value, is defined, then it can be used to assign the manipulator line, for instance. Yep. This is just like you treat this as a number indicated here. So practically, this is all I want to talk about in this series of quick and easy tutorial to programming in Rust or programming in general. So if there's any question, feel free to leave comments and I will spend some time answering the comments. And luckily that's it. And if you are in Malaysia, feel free to visit our site at rust-malaysia.github.io. We just added a link to GitHub registration. So you will be able to see our latest GitHub information here, including the date, the venue, really the agenda, what we are going to talk about, things we are going to do, and we will try our best to always post new things to the blog. As you can see, the last entry is March, which is very bad. Yeah, we'll try to find time to contribute more to the blog. And if you are an experienced Rust programmer, feel free to join us. I'll see you guys next time, I guess, if I have things to talk about. So for now, thanks for watching. Good night.